Today is our 19th lecture of analytic geometry. I'm the course instructor Ms. Mariam Fayaz from University of Education, Bank Road campus. Reinforcement, distance between the parallel lines. हम लोगों ने लास्ट लेक्चर में जो है डिस्टेंस फाइंड आउट किया था बिटवीन पैरेलल लाइन, ये इसका एक और मेथड है, उससे कुछ एग्जांपल्स को सॉल्व किया गया है by using the distance formula between the parallel line, which is already defined in the previous lecture. Two lines which differs by constant is known as parallel lines. Coefficient of x and y will be same. Journal form of equations of parallel lines will be in the form as shown in below. Ax plus by plus c1 equals to 0, ax plus by plus c2 equals to 0. Formula for the distance between two parallel lines is given by mod c1 minus c2 divided by square root a square plus b square. Note that if the equation of the parallel lines are not given in journal form, we have to convert them to journal form and find the distance between them by using the above formula. Practice problem. Find the distance between the following two parallel lines. If the lines are given 2x plus 3y equals to 6, 2x plus 3y equals to 7, then write the equations in journal form like that. 2x plus 3y minus 6 equals to 0, 2x plus 3y plus 7 equals to 0. From the above equation of parallel lines, we have a equals to 2, b equals to 3, c equals to c1 equals to minus 6 and c2 equals to 7. Putting these values in the distance formula, then we will get the distance between them. After substituting the values in the given formula, we have mod of minus 6 minus 7 divided by square root 2 square plus 3 square, which is equal to mod of minus 13 over square root 4 plus 9, which gives 13 divided by square root 13. Which is equal to 13 by square root 13 multiplied by square root. Now solving the factor square root 13, we are left with square root 13. So the distance between the given parallel line is square root 13 units. That shows that the parallel lines are square root 13 units apart. Similarly, we have another problem with different parallel lines. 4x plus 6y equals to minus 5, 4x plus 6y equals to minus 7, which clearly shows that these lines are parallel to each other because their slopes are equal. So write the equation in journal form. We have 4x plus 6y plus 5 equals to 0, 4x plus 6y plus 7 equals to 0. From the above equations of parallel lines, we have a equals to 4, b equals to 6, c1 equals to 5 and c2 equals to 7. Using the formula for the distance between these parallel lines in order to find out the distance, which is the shortest perpendicular distance between the given parallel lines. After substituting the values in the given formula, we are left with mod 5 minus 7 mod divided by square root 4 square plus 6 square, which gives 2 divided by square root of 52, and we are left with 1 divided by square root 13. So the distance between the given parallel line is 1 over square root 13 units. We have another example in which we have to find out the distance between the given parallel lines, and the lines are in the form x minus 3 by 2, which is equal to y plus 10 over minus 9 equal to z minus 1 over minus 2, and L2 is defined by x plus 5 which is over 4 is equal to y plus 3 divided by minus 18 equals to z minus 6 divided by minus 4. In order to find out the distance between these given lines, the direction vector of a plane, which is orthogonal to the parallel line is collinear with the direction vector of these lines. So the normal vector becomes 2i minus 9j minus 2k. Let the plane passes through the point A2, which is given on the second line by minus 5 minus 3 6. Then substituting these value substituting the value of that point in the general equation of the plane, which is given by ax plus by plus cz plus d equals to 0, which gives 2 times minus 5 minus 9 times minus 3 plus minus 2 times 6 plus d equals to 0, which gives d equals to minus 5. Thus the equation of the plane 2x minus 9y minus 2z minus 5 equals to 0, which is obtained after substituting the value of d. Besides the point A2 dash minus 5 minus 3 6 is the intersection of the second line. That point is actually obtained by the intersection of the second line and the plane. The intersection of the first line and the plane we calculate as x minus 3 by 2 equals to t, which gives the parametric equation x equals to 2t plus 3 y plus 10 over minus 9 equals to t, which gives y equals to minus 9t minus 10 and z minus 1 over minus 2 equals to t, which gives z equals to minus 2 plus 1. Hence, the obtained parametric equations are x equals to 2t plus 3, y equals to minus 9t minus 10, z equals to minus 2t plus 1, which implies that 2x minus 9y minus 2z minus 5 equals to 0. After solving these equations, we have 2 times 2t plus 3 minus 9 times minus 9 minus 10 minus 2 times minus 2 plus 1 minus 5 equals to 0, which gives t equals to minus 1. Substituting the value of t equals to minus 1, it gives x equals to 1, y equals to minus 1 and z equals to 3. Therefore, A1, the point on the line L, some useful links that are related to the topic which we have already studied and go through.